Bristol Community College, Mathematics with Dan Avedikian, Math 011, Arithmetic, Section 3.4, Problem 25. This is Section 3.4, Problem 25. It says a round above ground pool is 24 feet across. How many feet long is the wall of the pool? So a round above ground pool. So see how nice of a picture I can draw of that. So we have a pool. Something like that, full of water. 24 feet across. That's a fairly standard size. 24 feet across. So how long is the wall? So these pools, these round above ground pools, typically have a galvanized steel wall. That's one big long wall that you make the circle out of, put in the liner, fill it up with water. So how long is the wall really is how much distance is around the outside edge of that circular pool. So we're asking for the circumference. That's what you really need to realize. So basically this is a big metal circle that's 24 feet across. What's the circumference is what the problem amounts to. So circumference equals diameter, or the distance through the center, times pi. So the circumference equals the diameter or distance across for the swimming pool is 24 feet. And they have other sizes too. There's bigger and smaller pools. 24 is pretty common. But 24 times pi. Now some people will just leave the answer like this because some people want more accuracy or less accuracy. How many places after the decimal do you want for pi? It never ends. For most people though, a good number for pi is 3.14. So if I multiply 24 times 3.14, it'll tell me the distance around the outside edge of that pool, or in other words, how long the wall of the pool is. So to do a multiplication like this, again, if you can use your calculator, just run it into the calculator and get the answer. But if you're going to do it by hand, I prefer to write it vertically. So I'll put the 3.14 as the top number, the number with more digits I like to write on top. Not that it matters. You get the same answer if I put the 3.14 as the bottom number. But I'll multiply 3.14 times 24. Now, to do the multiplication with a decimal like that, as usual, just initially ignore the decimal. Multiply basically 314 times 24, get the answer for that, and then figure out where the decimal goes in the answer. So, to multiply, 4 times 4 is 16. Write the 6, carry the 1. 4 times 1 is 4, plus 1 more that you carried is 5. 4 times 3 is 12. That takes care of the 4, so if I go down a row, I want to start with a 0 in the rightmost position. 2 times 4 is 8. 2 times 1 is 2. 2 times 3 is 6. Then I can add the results together. 6 plus 0 is 6. 5 plus 8 is 13. For 13, I write the 3, carry the 1. 1 plus 2 is 3. 3 plus 2 more is 5. And then 1 plus 6 is 7. So without any decimals, I get a result of 7,536. But because I have decimals, that's not really the answer. So go back to the question, how many places did I have after the decimal altogether in the question? Only 2. And the 24 didn't have any place after the decimal. So in the question, 2 places after the decimal. In my answer, 2 places after the decimal, which would place the decimal between the 5 and the 3, giving me 75.36. Now, because this is an application problem that involves units of measure, I have to put the right units of measure in my answer. So my answer will be 75.36 feet. So if it's 24 feet across the center of the pool, the wall of the pool, which really is the same as the circumference, is 75.36 feet long.